Good afternoon, everybody. I guess this is the after lunch slot, so everybody's going to zone out. My name is Paul Reed. I'm a principal product manager in our AWS Boston office. I'm going to be joined on stage by two colleagues, Ian and Smitha. We'll try and keep it a little bit fresh, a little bit exciting to keep you guys awake after lunch. And this, for anybody that doesn't know, is the deep dive session on AWS transfer services. So why are you here? Well, you have a ton of IT resources today that sit within your data centers and within your offices. You want to move those to the cloud. So we're going to talk about moving the data that sits behind those resources. Now, that might be data that's tied to applications, data that sits on filers, dusty filers, somewhere in your data center, everybody's home directories, everybody's cat pictures, as people like to talk about. Data connected to your on-premises applications that needs to stay connected to those applications, but you'd like to move it to the cloud for a variety of reasons. Or data that you need to move between your site and AWS for workloads that may span your data center and the cloud. So why do you want to move data to the cloud? Well, maybe it sounds obvious, but you want to retire a data center. Maybe you're trying to get out of the data center business. Reduce your hardware footprint, reduce your capital expenditure. Management of all of this hardware is tough. It takes a lot of people, a lot of time, a lot of resources. Maybe you want to reduce your costs. Realize the economies of the cloud. Lots of reasons. Everybody has their own reasons. So let's look at what AWS offers in terms of data storage. So in the middle, you'll see our three core storage services for block storage, file storage, and object storage, represented by EBS, EFS, and S3 and Glacier. On the left-hand side, we have a set of services that help you move data into the cloud, into those core storage services. And on the right-hand side, there are a set of tools that work natively with those core storage services. Core AWS tools, as well as third-party tools. If anybody's been down to the expo, a lot of our partners down there live in the cloud. They work directly on top of these storage tiers. Before you begin to migrate data, there are 5 key questions you want to ask yourself. First is, what kind of data are you moving? Where's it going? What do you want to do with it once it gets to the cloud? We'll cover some of the use cases in a moment as we get further into this. Do you need to move that data continuously? It's continuously being updated. It needs to move into the cloud. The changes need to move. Are you moving it one way, or do you need to bring it back to your data center? If you have a manufacturing workflow, you need to move data into the cloud, perhaps process it, then you need to bring it back to tune your manufacturing facility. How much data and how long do you have to do it? If your lease is running out on your data center, you might have a time frame in which you need to move that data. And lastly, do you have enough network capacity to move that data from where it is today into the cloud? Do you have enough WAN, enough bandwidth? So at AWS, we have a variety of data movement and hybrid storage capabilities that will help you move into the cloud. We have a set of tools that work over networks, a set of tools that work over a different kind of network, the road network, and a set of tools that allow you to move the data but continue to maintain access from on-premises, this idea of being in a hybrid world where you're living in both the cloud and your on-premises data center. We have first-party tools from AWS, and we have a number of partners that provide offerings. Again, many of those are represented down on the expo today. Here's some of them. We have a very large partner network for anybody that is new here. We're not going to talk about the partners. They have other sessions, and as you say, they're down on the expo floor. You can go talk to them after this session. We're going to talk about the AWS offerings in this space, and specifically 2 offerings. First, I'm going to bring Ian onto the stage, who's going to talk about AWS Snowball, or the AWS Snow family, rather. And then I'll come back on stage and talk about AWS Storage Gateway.
There we go. OK. So as Paul was mentioning, there's more than one mechanism or service to get data into the platform. I'm going to cover a little bit around the uniqueness around the Snow family or Snowball devices, as you've commonly heard, and that they are pretty much the only physical device that AWS has out today. And we start with a question, which is, why did we build Snowball? Clearly, in many cases, network connectivity, whether it's 1 gig, 10 gig, 40 gig, now 100 gig, many can argue it's ubiquitous. But you'd be surprised. There's definitely a lot of use cases, even where network connectivity may be available. It's either intermittent or it's shared across many lines of businesses. And so if you're looking at moving petabytes of data or in that range of scale over the wire, it can actually take months to years. It just depends on really what's available to you for a particular migration exercise, be it one time or recurring. And then there's scenarios where it might not be a conventional data center where you're actually trying to move data from into the cloud. And so there might be forward remote locations, hardened locations where network connectivity might be satellite-based. Good example would be cruise line operators. If you think about the sat links that they have, not exactly very high broadband, and yet they have a need to pull data back into central cloud for mixed reasons, processing, archival, et cetera. In many of those cases, what we've seen is actually customers historically rely on just sending conventional hard drives or SSDs back and forth, packaging them up, sending them to a central facility or sending them to the cloud in some cases. And that's proven to be very laborious and error-prone. And so Snowball really provides a standard way that we can allow customers on a pay-per-use basis to ship them a device, have them fill that device up, or many devices in parallel up with data, and send that back to us. And so if we look at the Snow family, as we call it, from a big picture perspective, we actually have three distinct platforms. The first one, as we call the version 1 platform on the left, AWS Snowball, basically an 80 terabyte storage device with built-in 10 gig Ethernet networking. We provide full encryption end-to-end, meaning from the time you actually transfer data from your source array or source filer all the way to the time it lands into your actual S3 account. Your data is encrypted fully in flight and at rest. And it's a ruggedized form factor. We've tested it to 8.5 Gs, fully rain and dust resistant. And you'll notice there it has a little bit of a built-in e-ink display there that enables automated shipping, so there's no need to print shipping labels or air bills, and which again are error-prone and can be laborious if you're dealing with a lot of devices going back and forth. And then I'll call your attention to the newer platform, Snowball Edge. We bumped up a couple of the capabilities in this from a hardware perspective, so more storage, 100 terabytes. We expanded the network connectivity to include 25 and 40 gig E networking. The encryption is actually done on a hardware basis versus software on this platform, which provides a little bit more performance throughput. Same kind of ruggedized aspects, also rain and dust resistant. But where we took I think even a more pronounced different approach here is that we added compute capabilities to the device. And we started that by offering support for Greengrass and Lambda, so you could run Lambda applications at the edge for those that have already been accustomed to running serverless type of applications. And then as of today, this morning, we introduced a new feature, which is the ability to run EC2 instances on Snowball Edge. And by the way, you can run Greengrass, Lambda, and EC2 in parallel, so it's not one or the other, as well as obviously leverage the storage capacity. And then on the far right, we have AWS Snowmobile, which is, kind of consider the big monster, right? If you're doing a wholesale data center shutdown, migration, looking at exabyte scale of data offloading into the cloud, this is the appropriate platform. Many of the same capabilities that we see with Snowball and Snowball Edge, just a much bigger footprint. So let's talk a little bit around what the EC2 compute instances on Snowball Edge affords. And some of you might be asking, well, hold on, if you're talking about moving all data into the cloud, why in the world would I, including running processing in the cloud, why in the world would I want to have compute on the edge? And the simple answer is there might be application use cases, valid application use cases, where you probably can't wait for all the data to go into the cloud in order to start pre-processing or processing that data. In other words, there might be critical time-sensitive data that's being generated at some remote location, and you want to store that and also be able to do some kind of lightweight processing to feed back some insight into whatever application generated the data set in the first place. And so that hopefully provides you kind of a broad view on what the use case is for running EC2. In a nutshell, we have support for the C5 instance family on Snowball Edge. So as long as you actually have a C5 compatible AMI image, we will be able to run that. You see the table there that has 6 different instance sizes with different CPU memory footprints. The AMIs that we are actually supporting are 3 at GA, and so you can find those on Marketplace. They are primarily Linux-based for the initial launch. And then you see the max footprint there from a capacity perspective, 1.8 gigahertz Intel Xeon processor, up to 224 vCPUs and 32 gigs of memory. On the storage side of things, we can provision up to 1 terabyte drives for each of those instances, and that, again, is what we would consider in an augmentation to the actual S3 compatible storage that you have on the device, which is available as well. As far as how this works, pretty simple process. Just like you order snowballs today, you go through into the console, you select a particular snowball job that you want to configure. Usually the job type will dictate the actual form factor or the appliance type. In this case, you would specify a compute job, which would automatically select Snowball Edge for you. And as you're going through that workflow, you're going to specify a specific AMI image that you want to have configured on the device. That AMI image will be tagged or labeled as an S-AMI. The backend service basically passes that to our VM import-export function, which will do a conversion of that AMI to KVM. That KVM then gets provisioned to the Snowball Edge. Once that Snowball Edge is provisioned, we ship it out to you, standard 1 or 2 day shipping service, depending on what you choose. And then as the device arrives at your location, you power it on, do the basic hookup as far as network and power, and then you're back to using conventional EC2 command line interface to actually instantiate or bring up those EC2 instances that you had provisioned locally. Once you're done, same process as with Snowball today. You shut down the device. The electronic ink display automatically populates with a shipping label. We receive the device and completely wipe it. So there's no lingering application code or EC2 instances that are being kept on the device after the secure wipe process takes effect. So just to add a little bit more color around where do we see edge computing in effect, it's really a mixed bag. I would say, these are just some examples from research to industrial, healthcare, and transportation sectors. These are where we see either significant deployment of IoT-type applications, or really the characteristics that we're highlighting here from an application perspective is the data sets are highly decentralized. There's still a high velocity, or both high velocity and or high volume of data. And network connectivity is either inaccessible or intermittent. And those are kind of the constants, if you will, that drive edge compute application scenarios across these different sectors. So just a couple of quick call outs in terms of customers that are doing interesting things. Philips Healthcare, they've been actually iterating quite heavily using Snowball Edge to overhaul their health suite application, which powers medical devices that are used across 14,000 and change hospital systems around the globe. And really the idea is to be able to sustain availability of those imaging systems, whether there's internet connectivity or not, something that's been difficult to prove out in the past. Not only that, it's also the health suite itself being able to deploy that using standard AWS services, regardless of whether the initial deployment or the initial testing and deployment is done in AWS core and then being pushed out to the edge or vice versa. In the automotive space, this is actually pretty near and dear to my heart. We see a lot of investment and effort going into autonomous driving or advanced driver application systems. And the scale of data that's being generated is quite impressive. We have some customers that are in excess of 150 petabytes net new per month that's being generated. And so there's a constant struggle to figure out how do they collect that data, how do they process that data, and in some cases, as I was alluding to earlier, they're trying to figure out, is there a way to not necessarily transfer all of that data on a recurring basis if they can do some capture and analysis at the edge. So this is a very common example. And I think that brings us to hybrid cloud storage architectures. Back over to Paul.
Thanks, Ian. Thank you. That's super exciting. I'm really excited to see what all of you out there use the new EC2 instances on Snowball for. Pretty exciting announcement there. So I'm going to switch tack now and talk to hybrid storage. So hybrid storage is where you have applications that live on premises, and unlike needing to ship the data over a snowball, you still want to keep that application running, but it can accept the latencies of accessing storage in the cloud. So you want to store all of your data in the cloud and keep your workload on premises. So we think of that as hybrid storage. The way of getting to hybrid storage are using gateway products. So we're going to talk about AWS Storage Gateway as our gateway offering in this space. So you have a lot of data on premises today. Maybe it's sitting on traditional storage. Maybe it's sitting on devices in labs, manufacturing facilities. Your users access it. And they access it through a gateway. Now, when customers adopted Gateway, the service was launched in 2012. A typical first use case was to use it for backup, DR, and archive. Customers looked at the cloud and said, that's much cheaper than what I can provision on premises, so let me move my data to the cloud, move my backups to the cloud. What we're starting to see are customers adopting the cloud for much broader workloads and using Storage Gateway as their mechanism of getting there. Storage Gateway is a fully integrated service within AWS, and we provide storage natively within our storage services, so all of the downstream tools and products that work within the cloud on top of cloud storage work with the data that Storage Gateway brings in to AWS. As a service, we provide 3 types of storage, just as we have 3 storage services in AWS. We provide file storage through File Gateway, which gives you file-based access to objects stored in S3. Volume Gateway provides you block-based storage, stored in the cloud, accessible from on-premises, integrated with our EBS service for snapshotting. And Tape Gateway, which provides you tape storage, in addition to device emulation for a tape library, which allows you to replace a physical piece of tape infrastructure, a tape robot, with a virtual appliance that sits in your data center with all of your storage living in the cloud. So a really easy entree to the cloud for anybody that runs tape today and operates a tape infrastructure. No matter which type of storage you're using, which type of gateway you're using, the architecture is very similar. On the left-hand side, you see your applications, depending on whether your application needs file, volume, or tape storage. You deploy a virtual machine that you download from the AWS console on premises, which is the gateway. We offer an image for VMware and multiple different versions of Hyper-V, as well as an AMI for running in EC2. Your applications access that VM using standard storage protocols, NFS, SMB for file, iSCSI block for volumes, iSCSI VTL for tape. The gateway takes care of storing data locally, temporarily, and uploading it to AWS over an outbound, secure HTTPS session. Data only ever goes out of your data center. You can route it to a firewall or a SOCKS or a proxy server. Our backend service then receives that data and durably stores it in S3, EBS Snapshot, or Amazon Glacier, depending on the type of gateway that you're using. The VM provides 3 core capabilities. One is it's providing that protocol conversion from the protocols that your applications and users are used to today. Your applications don't need to change. Your users access what they think of as local storage using standard protocols. The gateway provides a caching layer so that applications see low latency access. They think of the storage as all being local to them on the gateway or in your data center. Really, it's all in the cloud. It's all being durably stored off in the cloud. In order to do that, we provide optimized data transfer. So we mediate between small reads and writes to files to larger puts and gets into S3, for example. It's a means of giving a more efficient way of moving data between your data center and into the cloud. Let's look at File Gateway in particular. So File Gateway is the newest addition to the family. We launched it at reInvent 2016 as an NFS File Gateway. We recently added SMB, and we'll talk a little about that in a moment. It allows you to reduce your on-premises footprint. Again, your clients, your applications, your users access what they think of as a local file or a local NAS. It allows you to reduce your on-premises footprint because you're just keeping a cached copy of that data in your data center, not all of your data. So you can get rid of some of that iron that sits in your data center. The cache is fully managed by us, and this is really important. You don't need to worry about sizing the cache or deciding on what data needs to live in the cache, what data is on-prem, what data is in the cloud. We fully manage the cache based on your workflow's access patterns against that data. We fully utilize the amount of local storage that you do give us in order to store that cache, but we take care of it for you. The cache is really just temporary storage. All of your data is actually stored in the cloud. So the gateway itself, that VM itself, becomes something that's effectively disposable. If you throw that gateway away, spin up another one pointed at your same S3 bucket, you get your file system back. We store all the file system metadata as well as the data on your objects in S3. Once the objects arrive in S3, we do a one-to-one mapping. So if you create a file called foo.txt, you get an object in S3 called foo.txt containing the contents of that text file. And as such, the namespace maps between your file systems and your object space, which allows you to use S3's capabilities natively. We don't create opaque objects with GUIDs. You can look at your S3 bucket and you can reason about it. You can write lifecycle policies to move things down into standard infrequent access, one zone, or even Glacier. You can tag objects. You can do cross-region replication with them. You can apply versioning to the bucket. The gateway has a lot of configuration that allows you to specify how that data should land in S3. You can do things like request to pays, guess MIME types. The same sort of things that you would do if you were interacting directly with S3 using the CLI or the SDK. We provide on the back of the gateway. Meanwhile, your applications think they're talking to files. Super neat. As I mentioned, we recently launched SMB to augment the NFS capability that we already had. So we now support NFS v3, v4, SMB v2, and v3. This allows your Windows workloads to store and access objects in S3 buckets much more easily than they could with potentially using NFS v3, which is supported on Windows, but the support is pretty poor for anybody that's tried. Works in your environment, you're running SMB. The gateway becomes part of your Active Directory domain. So the gateway authenticates itself to your domain. When your users come and try and access a share, we authenticate the user as a member of your AD domain to give you share-level access. And then when they're accessing files within that share, we're using, again, their AD credential to determine what they can and can't read within the share. Similar to NFS, ACLs are stored on the object. So file system ACLs, we support POSIX-style ACLs, similar to NFS. Unlike NFS, we do something that's very familiar to Windows users, which is ACL inheritance down the tree. So if there are objects already in your bucket, we'll look at a use case in a moment, potentially brought in by Snowball, they're going to inherit the ACLs from a file system perspective of their parent, because we don't really have file system ACLs for those. They were brought in directly. Let's look at why that cache is so important. We've talked about protocols. Let's look at why the cache is so important. What the cache is doing is it's providing this lens into your S3 bucket. It's providing a fully managed lens of just some of your data. Meanwhile, all of your data is stored in S3. So your file system clients see your entire bucket. Meanwhile, the gateway is keeping just a portion of that bucket locally and managing the pieces that your workload need at any given time. Cache is split into two parts. There's a data cache, which stores the contents of your files. We cache at a sub-file level. There's a really nice parlor trick you can do, which is you take a gateway, you give it 150 gigabytes of storage, and you start to edit a 1 terabyte video file. The gateway will quite happily handle that. You don't have to download the whole file into the cache before you can read or write it. We manage bits of files up and down to AWS, again, as efficiently as we can. Meanwhile, your file system application, your file-based application, is just reading and writing files as it would naturally. All data gets sent from the gateway cache up to AWS. So it's a write-back cache. When you write data, you get a synchronous response from the gateway. Your application moves on. It's written the data, and the gateway asynchronously uploads that. Again, we do that to sort of mediate between the file system protocols and their desire to sort of do small reads and writes, and the puts and gets we need to make to S3 to make that as efficient as possible. After we've uploaded data, we don't get rid of it from cache. It's still part of your application's working set, so we keep it in cache until we need space for hotter data, and then we'll evict data under the covers and pull in your new hot data. So we constantly manage that cache for you to keep as much data on premises as your cache will allow, the data that your application is currently using. On the metadata side, the story is similar. We keep a cache of the metadata for the file system. Now, the reason these are separate is that often you'll be doing file system operations, wandering around the file system, hunting for something, before you then go and read a file. So we keep separate cache of the file system metadata that in many cases represents many more files than your application will ever actually look into or read. Again, that's a fully managed cache. We take care of it. You can have billions of objects in your bucket. The gateway will know about the subset of objects that your file system, your file-based application is accessed at any given time. And we'll manage that cache automatically for you. So again, your file-based applications will see what they think of as a file system with billions and billions of files in it. Let's look at some of the use cases that customers use File Gateway for in order to transfer data into the cloud and live in this hybrid world. So following on from what we just mentioned around Snowball, we have customers that are using Snowball as a mechanism of bulk shipping their data. It's data maybe that they can take offline or they don't have enough network to move, many of the points that Ian made. And then they're using File Gateway to maintain access to that. In this instance, this was a customer that had a lot of data that was locked on LTO tapes. When they wanted to do analysis or look at that archive, it could sometimes take them days or weeks to get all of the data together. They'd have to find tapes, find the tape robot, download the data, untar it, put it into a file system. In this instance, they did that one time onto Snowballs, move that data into Amazon S3, have a File Gateway, present that bucket as a file system, and now their upstream applications can read and access all of that data. In this instance, in many cases, what they're doing is they decide a set of data is hot, their applications start to read and write it, they pull it into the cache, we do that under the covers for them. For a week, that data set is hot, and then some other part of the world becomes hot. In this instance, it's GIS data, for example. Some other part of the world becomes hot, their application starts to read a different part of the bucket, we'll drop out the data from the cache from the old location and pull in the new data that their application is demanding. Their application doesn't know about any of that, it's just reading and writing data from this giant S3 bucket. For them, another advantage is that the data lives in S3. For the coldest data, they can use some of our other storage tiers, Standard Infrequent Access or Glacier, to get a cost benefit as well for that data being stored in the cloud. Another use case for some of our customers is to use the gateway for content distribution. So in this instance, they have all of their data in a single bucket in one of our regions. They have a primary location that's reading and writing that data. In this instance, it's in Seattle. That application writes the data. The gateway uploads the data to S3. In the second location, they have another gateway that is looking at the same bucket in read-only mode. And the applications in that second location, it's in Boston, my hometown, can access all of the same data as the Seattle location from that same S3 bucket. The applications in both sides see local data, because again, they're reading and writing through that cache. So they see a low latency access to the data that they care about. Meanwhile, you have a single master copy of that data sat in S3. The last use case I'm going to cover before Smitha comes up and does a demo of use case number 4, I guess, is low latency content editing. So in this instance, we have a customer that keeps a content repository in Amazon S3. It's fairly sensitive, IP-related media files. They really don't want to have that data stored on servers that potentially they could lose it from. Somebody could stick a thumb drive in and copy it all down. So they master it all in S3, keep fairly tight control of it using IAM policies in S3, and provide users access, editors in this instance, access to that data through a gateway. The gateway, again, has that transparent cache that their editing workstations can see. The two editing workstations see what they think of as a fully POSIX-compliant file system. They're both connected to the same gateway. They expect a file system. They see a file system. Meanwhile, the gateway is making sure that all of the data is durably stored up in S3. And in this instance, none of the customer's data gets lost. So I'm going to ask Smitha to come up and show the last of our use cases that many of our customers are using, which is to use our new SMB capability to store data coming from SQL Server, a Windows application, in S3.
All right. Thank you, Paul. I'm going to move to the next slide. Yeah. Hello, everybody. I'm Smitha Sriram. I'm a product manager in the AWS Storage Gateway team. So today I'm going to do a demo of one of the common use cases of File Gateway, which is using the gateway to back up SQL databases directly into Amazon S3. Right, so what you're seeing here is the architecture that's behind the demo, what I have. You'll see that I have a domain controller, and this represents, this could be your local Active Directory. That's either Microsoft Active Directory on-prem, or even an in-cloud option like AWS Directory Services. And then we have the SQL Server that's running on-prem. And then your gateway that's local, your gateway VM that's running, and as Paul pointed to, it has its own local cache, and you've exported a file share using SMB. On the cloud side, you have your S3 bucket, where all the backups will go into, right? That's your Amazon S3 bucket. And as you can see, you can run lifecycle policies on that so that the data can get moved in, that can get lifecycled automatically into Amazon S3 infrequent access after a certain number of days, or even archived directly into Glacier. And then there are other interesting things you can do in this data once it's in S3. I'll touch upon CloudWatch events and some of the targets that you can use depending on what your use cases are. So with that, I'll move into the demo side of things. 1 second here. Press the demo button. So I put my computer.
Mentioned that to me. I don't know that it's going to come up. No, it's not reading it. It's not reading it. What's your output? It's not reading this computer.
Oh.
It's not reading it. I'm telling you, it's not seeing it.
Okay, I was told that it's HDMI would work.
No, I know, but the output you have.
So I'll just talk through this, what I was going to demo to you. So in the AWS Management Console, I have my gateway, and then you'd get the gateway to join your AD domain. Once you do that, you can create an SMB file share, and that file share, you'd set it up so that it's backed by your S3 bucket that I'm showing you right here. I also had it set up here so that I had a Windows machine where you'd run your on-prem SQL Server, right? And within your SQL Server, you could use SQL Server Agent, right, to run a script so that what it would do is take your daily backups, right, write it into S3. And how we would write it into S3 is it would see it as a local file share, right? You would have an IP address, and then you'd have a bucket name so that it's pretty intuitive on how the SQL Server thinks that it's writing to a file share, but then you'd actually see these backups directly exported into Amazon S3. The second part of my script also involved asking for a CloudWatch event. So once this data is in S3, like as Paul mentioned, the gateway writes synchronously locally to your disk, but it asynchronously uploads this into S3. So you want to know when this is in S3, right? So you can request to say, send me a CloudWatch event once this data is written into S3. So once this data is in S3 and the event gets fired, you can use one of the other AWS applications as targets to the event, right? So one of the examples is Amazon SQS, which is simple queuing service, right? With simple queuing service, what you can do as a Windows admin is have a script on-prem from your Windows box polling this queue so that once that notification is there, you can have it directed into your application event log, right? So you might have a script that's reading your event viewer that says, okay, this database is now backed up durably in S3. The other part of the demo had, you could have a CloudWatch event that targets an Amazon SNS, that is simple notification topic. You would have subscribers to SNS who are interested in this, right? I mean, in this case, it would be your database admin. They want to know when this data is in S3, when it's stored durably in an offsite location like S3. The other example is automate in-cloud restores, right? You may have a Lambda that kicks off, takes this backup file, kicks off an in-cloud restore to make sure that the database backup file is in a position to be restored. So there are a lot of options for you once this database is stored durably in Amazon S3, including lifecycle and archiving. If I were to do the demo, so which would have taken just less than 5 minutes, what would you have done? Yeah. Okay. No.
No.
Sorry. So this demo would have taken 5 minutes, like I just said. And so within 5 minutes, what would you have achieved, right? You would have taken data generated by a local on-prem application, which is your SQL server, right? Stored it up into S3. And then the other part that you could have done is from your local database, restore a backup file that's stored in S3. Because remember, the application sees it as a file share, right? So you can go bring that data back down. All of this in a matter of 5 minutes if I could have done the demo. Thanks.
Thanks, Smitha. The demo gremlins are with us today. That's okay. So as a good cooking show always says, we do have one that we baked earlier. So we actually did a webinar earlier this week, or earlier this month rather, in which we did this demo. And so if you go to aws.amazon.com/storage gateway, you can watch the webinar in which one of our storage specialist SAs did a demo of this very setup in all of its glory. So my apologies that the demo didn't work today, but we have it online, and you can go and see it there. In the last part of the talk today, I'd like to cover the other two gateway types that we have. So we mentioned that there is file, volume, and tape storage from Storage Gateway. So I'd like to cover volume storage and tape storage as we close out here. For volume storage, what we're providing you is block storage on premises that's backed by the cloud. So in this instance, the gateway is providing you an iSCSI target that your initiator connects to, and he sees a block device. The gateway, again, is going to cache some of your data locally or store some of your data locally, and he's going to manage that data up into AWS. Now, for block storage, we don't put it in your S3 bucket. Sort of opaque blocks of a block device wouldn't make a lot of sense to you, but we allow you to take snapshots of those on-premises volumes, which become EBS snapshots once they get onto the AWS side. We'll talk about what you can do with those EBS snapshots later, because you can use them both back on premises and to create EBS volumes, which you can attach to EC2 instances, which give you a whole variety of use cases around data movement, data migration, and disaster recovery. The volume gateway comes in two types. We've talked a lot about low latency caching that File Gateway provides. The volume gateway also introduces a stored mode. Now, this is really useful for applications that don't have a working set of data that fits neatly into a small cache. In this instance, you want all of your data stored on premises, but you want that copy in the cloud, that DR copy or that backup copy in the cloud. So in this instance, the gateway sits between a physical LAN on-prem and your application, and make sure that as you write data to that LAN, as you change that block device, all of that data gets uploaded into the cloud, such that if that block device is lost on premises, you have a copy that's safe in the cloud. Meanwhile, your application has all of its data locally, and so has low latency access to the full volume, the full block device. In cache mode, it's very similar to what we mentioned with file, whereby you have access to a full volume, but only some of it's going to be kept locally. So again, use cases where the working set of data is smaller than the LAN, and you have a small amount of storage on premises. A single gateway can host 32 terabyte LANs. That's about a petabyte of storage accessible to your application. And all we ask for that is a minimum of 150 gigabytes of local cache, local storage. So a petabyte of storage through 150 gig. Again, with cached, all of your data is stored in the cloud, so the gateway itself is disposable, can be decommissioned, and you have access to the data that's in the cloud as a block device, either through an EBS snap or through the gateway itself. There's two mechanisms of recovering volumes with either cached or stored volumes. It doesn't make a difference. The feature's the same. You can create EBS snapshots of your volumes, which become sort of the lingua franca of block devices within AWS. Or you can do volume cloning. So if you want to do a rapid restore of a volume to a gateway, maybe you have a test data set that you want to keep cloning temporarily. or you're doing a DR failover between two gateways, simulating disaster recovery of your primary data center, you want to spin up a DR version of the same data sets, you can get a clone of that volume in real time and expose it to a downstream application in your recovery site. So the gateway provides you 3 restore scenarios in this case for volumes. You can restore them back on premises, option 1 here, back to the same gateway. You can restore them to a secondary site, DR, option 3, or you can restore them in cloud. We have a number of customers. Here's one who is a longtime user of Storage Gateway. They adopted the service way back in 2012 when it started, and have been strong proponents and strong users of it ever since. They're using Volume Gateway in this instance in order to provide a variety of storage for their users. They have multiple offices, 10 offices, I think, where they're using Volume Gateway to give them that on-prem storage durably backed by the cloud. They use both VMs on premises to provide primary storage to their users, and they also use our EC2 Volume Gateway in cloud for some of their restore scenarios where they take a snap of a volume, restore it in cloud, pull some data off that snap, and then decommission that temporary volume. The last gateway type I'd like to cover is tape gateway. Unlike our volume and file gateways, we provide more than just a new protocol here. We're also providing device emulation. And this allows you to replace physical tape infrastructure, which is more than just storage, with a virtual appliance backed up by the cloud. Tape becomes this drop-in replacement for your existing tape infrastructure. And we work with all of the leading backup vendors shown here, such that those applications interact with what they think of as a virtual tape library. Meanwhile, all of your storage is in the cloud, and we take care of integrating that without really having to think about that going to AWS. So for a backup admin, they work in a natural way. They work in their backup application in the way they're used to, and the gateway takes care of moving their data into AWS. One of the nice things about Tape Gateway is that we map some of the capabilities of the backup application into things that we can naturally do within the cloud, and the big one there being archival of data. So when a tape gateway, or when a backup application asks to eject a tape or to export a tape, in the physical world, you'd take that tape and you'd send it off-site for long-term storage. If your backup application asks to eject or export a tape against Tape Gateway, we take that data on that tape and we move it down to Glacier for long-term, low-cost storage. We have customers that keep a very small set of their tapes in their library, in the robot, if you like. And for that, they pay SV standard rates. But they archive tapes aggressively. They have a huge, long-running archive of tapes. They have, in this particular customer's case, they have a 50-year retention on that tape. So they're moving it down to Glacier as quickly as they can and storing it at that lowest price point. What's the cost savings that people realize when they move from physical tape to virtual tape? This was an example of a customer up in Massachusetts who sort of did the cost study. What you have to remember with tape is it's more than just the storage. You have a whole set of additional costs managing that infrastructure, moving from LTO4 to LTO5 to LTO6 to LTO7 to LTO8, managing the libraries, making sure that the copies are durable, making sure that you've done fixity on the tapes. Tapes rot, physical media. Moving to AWS, their costs became a little bit less than half. In this instance, a lot of that maintenance and management that they had of that physical infrastructure goes away. We take care of running the fixity, we take care of making sure the data is good, and they can worry about a very flat operational cost as their data grows and not have these spikes of having to invest in physical infrastructure, maybe buy a new robot, a maintenance agreement and such. So how does Tape Gateway work? Again, it's a cached model. In this instance, we provide a cache of the data. We recommend customers keep perhaps their most recent sets of backups on premises in that cache, so that if they need to do a near-term restore, the data's already in cache. They don't have to fetch it from AWS. We move all of your data to AWS. So you can actually think of your tapes stored in the cloud, and the service itself is really just providing you access to that. We have many customers that come to us and say, oh, my tape is stuck on my gateway. The tapes are really in the cloud. The gateway is just really providing you access to those tapes through protocols that your applications understand. We do tape drive emulation and media changer emulation. So again, your application upstream just thinks it's talking to a physical tape library. When you want to bring a tape back from archive, we do that at standard Glacier rates, 3 to 5 hours. Don't know an offsite vendor that can bring tapes back to you that quickly. So you can get your data back when you need it, if you need to pull data back from archive and do a restore. That concludes the presentation today. Thank you for coming. I would like everybody to submit feedback. And if anybody has any questions, please fire ahead. Dylan in the back there has a mic, and we are recording this session, so it's nice to hear the questions.
So I work with the New York Genome Center. We back up petabytes of data on site. We sometimes pull it back for reanalysis that the scientists do on a yearly basis. And I think one of the reasons why we went with an on-site system is because pulling back data from Amazon has traditionally been very expensive. Is there any change in that cost structure?
So the way that you would get charged with Gateway is the same way you would get charged with other services, where you will pay for data transfer out. A lot of customers that have angst about that look at things like Direct Connect as a way of buying connectivity that not only gives them guaranteed bandwidth, but also comes in at a lower price point, and in fact, there are other ways of paying for storage. So Gateway doesn't change that dynamic. So if it doesn't work for you, then we haven't got anything today. Maybe it's worth a discussion afterwards to talk about some of the things that we do have coming up that may address yours. Ian can take questions on Snowball as well. And Snowball export, right? Snowball export is a way of doing it as well. Sorry, thank you, Ian.
I was wondering, for File Gateway, what's the procedure for retrieving things out of Glacier?
So in this instance, for data that's in Glacier, that mirrors the semantic that you would get with S3. So you can see that the file exists. You can see the file system metadata about the file. But if you go and read the file, you get the equivalent of a file in wrong storage class. If you're hitting S3 directly, you get an I/O error. We're looking at making an enhancement to do things like auto retrieval and for customers that do have a lot of their data in Glacier, and the application can tolerate that latency of pulling data back from Glacier. That's something that, again, we'd like to talk to you about what your needs are there. We think we know what we want, but we'd like to sort of validate as much as we can. Just to add to that, if you transition an object back up from Glacier into standard, you can now start to read and write it as you would normally. So it's really just for objects that remain in Glacier. You need to wait for the retrieval to get access to it. Thank you.
A use case I'm looking for is, in our company, we use a Barracuda device to back up our on-prem VMware virtual servers. Our maintenance is expiring on that soon, so looking for something possibly to replace that. Would you recommend for our scenario, would you recommend maybe the tape gateway to do that? And would that allow full VM restores as well as individual file restore level? So and how could we use that also for a DR scenario?
Yeah, so tape gateway is a good option if you're already potentially using tape or you're already used to tape. A lot of customers that adopt tape are trying to get off physical infrastructure, and it becomes a very easy entree into that. Obviously, you're dealing with tapes, so from a restore scenario, it's whatever you can do with tape, depending on what your upstream backup application supports. We're also seeing a lot of customers using file now for backups. Because of that one-to-one mapping between files and objects in S3, the ability to manage and use the S3 capabilities in cloud to deal with that data from a retention and archival standpoint. So if you're sort of thinking that you're wanting super granular restores, maybe restoring VMDKs or individual files out of those VMDKs, then I'd look at probably more of a file solution rather than a tape solution, because again, there's a number of application layers that are going to sit in the way of getting individual things off a tape. Whereas with file, you're a little bit closer to the things you're backing up, because they're not so rapid in a different sort of media type, if you like. So.
When we use volume gateway and then tape gateway, can Macy do PIA scans on the data in S3?
Can you see the data in S3 that you? Was that the question? Sorry.
Can we use Macy to do the PII scans and?
Can we use Macy? Nah. So with both volume and tape gateway, obviously we're storing data on blocks. It's a block device that you're reading and writing from. And so we store that actually in service buckets for you on your behalf. So in that instance, it's not going to be visible to you in S3 or any of the other services that would integrate with your S3 buckets. For volume, we allow you to create EBS snaps, which is sort of the egress mechanism in cloud for volume storage. One of the things that we have heard customers want us to do on the volume side is provide more granular access to that data, and I think that's where you're going. And again, I'd love to talk to you about what the specifics of your use case, because it sort of treads a little on the gentleman behind you where you want to pull individual things out of block devices, where there's multiple layers of application in the way of how that data was actually put onto the block device. In most cases, it's a file system, right? Unless I know what file system you're using, and I can't get files off a block device for you. But certainly, as we start to integrate with this broad portfolio of things like AI and ML, it'd be really interesting to understand what you're trying to get at there and figure out how we can do that for you. Is that everybody? Oh, one over in the... If you shout, I might hear you. It's a big room.
In order to take the native SQL backup to Amazon S3, so is there any limit for the database size? Like a single file in S3 is 4 TB, limit is there. So I have a database like 17 TB. So can we take the backup of that database to the S3 directly?
So File Gateway is going to allow you to create files up to the maximum size of an S3 object. I would suspect a 17 terabyte single file, even in most file systems, is a fairly immovable part of storage. I don't know the specifics of your backup application, but many backup applications will allow you to shard single backups into multiple files, and you could shard it down at 1 TB or smaller. But File Gateway doesn't allow you to go beyond, create objects larger than the largest S3 object size.
In the native SQL backup, we can do that segregation of the backup 17 TB into multiple files. Mm-hmm. So well, can we do that to S3 by using the native SQL backup? We can do it in file share system, but in S3, can we do that?
I don't know the specifics of SQL Server's integration directly with S3, but if you were to write those files to a File Gateway, it will take care of creating the objects in S3.
All right, thank you.
Any more? Thanks, guys. If anybody didn't want to ask a question in public, I'm more than happy to do one-on-ones as well. So we do have one more here.
Hi. So we are currently doing backups using Veeam software and Commvault to disk, and we in turn take it to tape. We would like to, use S3, and what is the best way for us to go about doing cloud backups in this scenario where we want like about 30 days of data on-prem, and then after that we just upload it to cloud?
So both Veeam and Commvault are applications that are backup apps that Tape Gateway will work with. And you're already doing backup to disk, backup to tape. So an easy step that we see a number of customers do is to replace your physical tape with Tape Gateway. And customers will do that in a variety of ways. They'll sometimes run just parallel copies just to get comfortable with it, and then eventually replace the physical infrastructure. So you've maybe got backup to disk and then backup to tape through the Tape Gateway. Now, the thing that you then start to realize is that the Tape Gateway is keeping that cache of data locally, which is potentially your 30-day supply of near-term restores. So unlike tape where everything's offsite and everything's slow to access or to pull back, you could actually back up straight to the VTL as your primary and size the cache behind that gateway to absorb 30% of your 30 days worth, of your backups. In which case, a restore from those tapes are going to come back at local speeds because it's all in the cache. Meanwhile, all of your data is on the cloud, which again gives you an additional level of protection to what you have today, where your backups, unless you're backing up to disk and doing an immediate copy to tape, till that copy of tape goes off-site, you have no off-site copy of that data. So there's a variety of different ways of sort of stepping into it, depending on how your sort of tolerance for change within your environment. But we do see this journey for a lot of customers where they'll slowly replace their tape infrastructure with virtual tape, potentially replace their disk infrastructure, depending on where they're comfortable with. Or certainly Commvault, I know, has a direct to S3 connector. So a lot of customers will use Tape Gateway as a means of getting comfortable with storing data in the cloud, working with AWS, understanding the cost structure there. And then after a period of time, we'll potentially use one of the backup application's native connectors to move data directly into S3 and sort of sunset the idea of doing tape altogether. So it really depends on your sort of how big a step you want to make initially. But there is a journey here that many have taken before you. Thanks, everyone.